Good evening, and welcome to the Scientific Adventures of Beardman. Today, we're going to take a look at some of the numbers associated with the acidity level of a solution. How much of an acid is it, or how much of a base is it? Before we do that, let's just review a little bit. An acid is something that has H+, or donates an H+, or accepts an electron pair. We're going to focus on the donating of the hydrogen here as we take a look at water, because water is a special kind of substance. It can both donate a hydrogen ion, or accept one. And so we see that water can do both. When you have a glass of water, it's actually auto-ionizing all the time. And because it acts as both things, it's a substance that's called amphoteric, meaning it's both an acid and a base. So if we look at this equation here, we can see that if we have H2O and H2O, one of the H2O molecules can give up the hydrogen. A molecule donating a hydrogen would be an acid. And then the other water molecule could receive that hydrogen ion and becoming hydronium, and in that water molecule would be the base because it's receiving hydrogen ion. And so we can see that the one losing the hydrogen is acting as an acid, and the one receiving it is the base. So amphoteric, it acts both as an acid and a base. So the question is, well, how often does water do this? When we got this cup of water, is this going on all the time, like every molecule is constantly doing this? Well, we can judge this by looking at concentrations. And so if we take the concentration of hydrogen times the concentration of, concentration of hydrogen ion times the concentration of hydroxide ion, we then get the ion product constant, also known as the ionization constant, or sometimes auto-ionization constant. Symbol for that is Kw, K sub W, as we see here, capital K, subscript capital W. And the value for that is 1 times 10 to the negative 14th. Okay, so the concentration of hydrogen or hydronium ion times the concentration of hydroxide ion is incredibly small. In a neutral solution, those would be the same, because every time you auto-ionize, you create one of each, and so that means each one would be about 1 times 10 to the negative 7th, meaning 1 in every 100 million molecules would be H+, and 1 in every 100 million, 1 in every 10 million would be hydroxide ion. So that's pretty small, 1 in every 10 million. But that's what it is, and so we get this equation, Kw equals the hydrogen concentration times the hydroxide concentration, which equals 1 times 10 to the negative 14th. So, now if we add some acid to this water, or a base, we play with that amount of H+, hydrogen ion, or the amount of hydroxide ion. So if we add an acid, we increase the amount of hydrogen ion. That would decrease the amount of hydroxide ion, because the hydroxides that are there will more quickly find a partner and become water again, and therefore they will not stick around as OH- as hydroxide. And the hydrogen plus ions will then outnumber them, and so we'll see a shifting of that balance. But keep in mind, if we're in an aqueous solution, the product of those two concentrations always has to equal 1 times 10 to the negative 14th. So as you can see, the hydrogen ion concentration is represented by H plus with a bracket around it. The bracket means the concentration of that in molarity. And the hydroxide ion concentration is the OH minus with the bracket around it. That indicates the concentration of hydroxide ion. So we might get a problem something like this. Calculate the hydrogen ion concentration given that the hydroxide ion concentration is 2.0 times 10 to the negative third molar. Okay, so we set up our equation, first we list our givens. We see that the hydroxide concentration is 2.0 times 10 to the negative third molar. We know that Kw is 1.0 times 10 to the negative 14th molar. And we can, and our unknown is the hydrogen ion concentration. So we write down our formula, Kw equals hydrogen ion concentration times hydroxide ion concentration. We rearrange to solve for hydrogen ion concentration by dividing both sides by hydroxide ion concentration. We can see they cancel out over on the right side of the equation here. And then we can plug in our values for the Kw, plug in 1.0 times 10 to the negative 14th molar, and we plug in for molar squared, and we plug in for the hydroxide ion concentration, 2.0 times 10 to the negative third molar. When we divide by those, we get that the hydrogen ion concentration is 5.0 times 10 to the negative 12th molar. Okay, we can see there that the hydroxide ion concentration is increased to only 10 to the negative third. Okay, and that has decreased the hydrogen ion concentration to almost a trillionth of 1. Okay, 10 to the negative 12th. All right. So one thing to notice is to keep in mind is that when we see that the hydrogen ion concentration equals the hydroxide concentration, in other words 1 times 10 to the negative 7th and 1 times 10 to the negative 7th, we have a neutral solution. When we see that the hydrogen ion concentration is greater than the hydroxide ion concentration, we have an acidic solution because we have more H+. And when we see that the hydrogen ion concentration is less than the hydroxide concentration, we have a basic solution because we have more OH minus. Okay, like in this last situation where we had more hydroxide ion concentration. Now keep in mind, because we're dealing with negative exponents, the smaller the negative exponent, the bigger the number. When we have 10 to the negative 12th, like in this last problem for the hydrogen ion concentration, that was an incredibly small number, 10 to the negative 12th. Okay, so as you can see here in this little chart, that the hydrogen ion concentration, as it increases, in the first one over here, as that increases, the hydroxide ion concentration decreases. So that would be an acidic solution. When they're equal, it's neutral, and when the hydroxide ion concentration is greater, it's a basic solution. Okay, so let's do one more problem. If the hydrogen ion concentration is 1.0 times 10 to the negative 5th molar, what is the hydroxide ion concentration? And is this solution acidic or basic? Okay, so we list our given and our unknown, and we write our equation. We rearrange our equation to solve for hydroxide ion concentration. We plug in our values, and we get that the OH concentration is 1.0 times 10 to the negative 9th. Since 10 to the negative 5th is greater than 10 to the negative 9th, that means we have more hydrogen ion concentration, and therefore this must be acidic. And that brings to a conclusion our lesson on the ionization constant and the relationship between the concentration of hydrogen ion and hydroxide ion. Thanks for listening. Have a great week calculating concentrations. Be sure to concentrate. See you next time.